We are the Penn State Lunar Lion project, and we're going to the moon. And the way to get there from Earth is first, build something that you know works. Then, send it to the moon. And the way to do that is we're going to create a prototype craft that has a lot of the capabilities that our final craft will, just a simpler form of it. And that'll allow us to create a control system and verify that when we are trying to go on the moon and hop from point A to point B, then we don't crash along the way. And so we need to know with good certainty, if this is the surface of the moon, we go here, we go over there, 500 meters away, that we're not going to crash along the way. And the way to do that is that you don't just create a plan. We're not going to create a rocket, send it there. We're going to test things here on Earth. We need to build a prototype that has a lot of the capabilities. And what that means is creating a rocket-powered craft which is capable of flying on Earth and then landing again. So it's vertical takeoff, vertical landing. Obviously, we're not on the moon, and building a prototype that works on Earth is not as good as building a prototype that you can test on the moon. Fortunately, it's a little bit difficult to get to the moon to test a rocket that you want to send to the moon. So we're going to be testing here on Earth. There's additional things that make it harder to test here on Earth than on the moon. For example, the gravity is about 6 times stronger here on Earth than it is on the moon. And what that means is that since we're building our prototype to go on the Earth, and the gravity on Earth is a lot stronger, we need to have a lot more propellant in order to get from point A to point B. Essentially, our gas mileage is going to be a lot lower because of the extra gravity. So kind of like if you took an SUV to get from here to across the country, or you took a Prius, then you could get to the other side with a lot less fuel. Actually, we are looking into green propellants. A green propellant is something that's not toxic. A lot of the propellants have been used in the past. They have been used because they're very high energy, but they're also very, very toxic. And these propellants have been very hard to work with because you have to have people so far away from everything. So we're going into our makeshift lab, which is just the first step until we're at a little bit better of a spot. Just to give people an idea of the reference, is that if the Earth is here and it was actually this big, then the moon would be all the way over there, 25 feet away, which is on the opposite side of the room. The moon is a lot further away than most people realize. The moon is actually about 250,000 miles away, which is about roughly 39 times the diameter of the Earth, or 125 times the diameter of the moon.
The most complex part of this whole test stand is the fact that we had to have a way to make it be able to move in all directions, including rotation, all completely freely, so that we can accurately test the control system. It is just a system of these different cubes that are kind of inset inside one another, and it allows it to rock in all sorts of directions. There's a toy that I've seen at planetariums and stuff, which is a bunch of concentric circles that can all rotate inside of one another, and that's kind of what reminds me of how this works. Eventually, we're going to make it so it can also go up and down. Right now, we've got it locked in the vertical up and down direction to try to make it a simpler control scheme. But eventually, once we can get it balanced so it doesn't rock like this, we're going to try to move it up and down, and then our next step will actually be, I believe it'll be free flight. We're still going to have to tie it down because this stuff isn't quite heavy enough to stop this from flying off on its own. But it should be sturdy enough to make it so that it will not fall apart mid-flight. So.